So in this activity, I'm going to go through all of the goal state and Canvas problems with the idea that if you were absent on the day that the activity was assigned last week, that you're able to at least see the problems being completed in its entirety. For those of you that were in class, it's a quick review of some of the main concepts and some of the tools that are available to you through graspablemath. So with quadratic formula, with graspablemath, we can only do either the addition or subtraction problem with goal state. With Canvas, we're allowed to set both problems, addition or subtraction. So when we get to the Canvas problems 5 and 6, we'll see the complete problem of the quadratic formula being done. So in the numerator, we're going to take the 2 times 3. Anytime we see kind of a shimmy that tells us that we're trying to do cannot be done. So multiplying by, or 7 squared gives that 49, or actually negative 7 squared. If I try to do subtraction, I can't do it because multiplication gets done before the subtraction. So we end up with 3 minus the square root of 1 all over 6. The square root of 1 is 1, so we can actually simplify this to get 2 6. You'll notice that the goal is 1/3. Sometimes there are common factors between the numerator and denominator. In this case here, the 2 and the 6 both have a common factor of 2. So if I put the 6 on top of the 2, it breaks it into the factors. So 2 divided by 2 is 1, and we get that final answer of 1/3. Make sure you're clicking on the continue or submit button. Please watch the video. If you have not, I would recommend even going back and revisiting the video. For goal state, we're doing the same thing again, taking care of the exponent first, multiplication problem. Click on the parentheses to get rid of the parenthesis. So we end up with a negative number here. In the denominator, we get 2 times 1, which is 2. Because we have a negative, as we've talked about before, that means we have a factor of the square root of negative 1, which Euler has defined to be I. And then 36 itself, we can break that down if we need to into a perfect square factor times a non-perfect square. Sometimes we get a perfect square factor, which in this case we do. 36 is 6 times 6. So we can break this problem down to negative 1 times 36 and replace negative 36 with this multiplication problem. The reason we're doing that is because graspablemath cannot do the square root of negative 36, but it can do the square root of negative 1. It's defined to be I. And it can do the square root of 36, which is 6. Put the 6 before the I, so we get negative 2 minus 6i over 2. You'll notice that we have a different answer here. The reason why is because both 2's and the 6 have a common factor of 2. So if I pull the 2 up in the numerator, you'll see the blue rectangles, which tells me it's going to make a fraction out of it. So 2 divided by 2 is 1, and 6 divided by 2 is 3. It separates it for us to let us know the common factor is 2. So 2 divided by 2 makes 1. In the next Canvas problem, very similar steps. So we're going to simplify this, see what we end up with. This time we have, again, another negative 1. So if I click on the negative 72, we have negative 1 multiplied by the 72. 72 is not a perfect square factor, so we're going to try to see if we can find some numbers that work. So using calculator, 17 divided by 4, it gives me 18, so that one works. But again, I'm trying to look for the biggest number, so if I take 72 divided by 9, I get an answer of 8, so that's a better choice. If I try to do 72 divided by 16, it will not work. I get I get a decimal number. If I do 75 divided by 25, or sorry, 72 divided by 25, I get real close to 3, but again, it's a decimal number. If I do 72 divided by 36, I get a final answer of 2. This actually is the largest choice, and it's like simplifying fractions. We're looking for that greatest common, in this case, perfect square. That greatest common perfect square, so that we can simplify the fraction, or sorry, the square root once. Click on done, and it replaces the negative 72 with 3 factors. To simplify this, we're going to pull the numbers out in front to create 3 separate square roots. The graspablemath will replace the square root of negative 1 with I. The square root of 36 is 6, and the square root of 2 is square root of 2. So the reason for that 3 square roots is that we have 1, which is the negative 1, which is the I. We get 1 perfect square factor, and then the third one is the non-perfect square factor that we simply leave alone because it can't be simplified. We get an approximate decimal number, but it cannot be simplified since it's not a perfect square. Now again, you'll notice that we have a fraction and our final answer is not. 6, 6, and 6 all have common factors of 6. So if I simplify 6 divided by 6, I'll get 1. If I do 6 divided by 6 this way, I will also get 1. So I end up with negative 1 plus I root 2. When doing the canvas problems, we're going to use quadratic formula, so the opposite would be. So this should be a positive 3. You'll notice that if I click on the parenthesis, it makes a negative 3. It's supposed to be the opposite of negative 3. So we do have a keypad. So we click on the keypad and we're going to replace the negative 3 with a positive 3. It's going to ask us, do you really want to do this? And the answer is yes. So graspablemath, I mean, like all programs, there always are some errors or issues with them. You have to be careful what you're entering and make sure it's being done correctly. So for example, this should be negative 3 squared. So if I pull this down, you'll notice that the negative sign did not go with it. So we're going to replace, using keypad, replace the 3 with a negative 3. It's going to ask the same question, do you really want to do this? The answer is yes. And that's minus 4 times the A value times the C value, all over 2 times the A value. Because of spacing, we can click on the smaller to make the problem a little bit smaller. When we come over to the right side, we're going to have the same issue. I'm going to pull that 3 down. It should be a negative or positive 3 at the beginning, not negative 3. So we're going to use the keypad to replace that negative 3 with a positive 3. I put the negative or 3 in here. It should be negative 3, not positive 3. Everything else seemed to work fine. So 4 times 2 times 5. All over 2 times 2. I'm not going to complete all the problems in terms of the canvas, but I will take a look, have a look at the left side with you so that you can at least see what you should end up with. So we end up with 3 plus the square root of negative 31 over 4. This over here should be 3 minus the square root of 31 over 4. The square root of negative 31, coming on a keypad, tells me I can separate this. So I definitely need a negative 1. Then the 31 doesn't have a perfect square factor, so 4 doesn't work, 9 doesn't work, 16 doesn't work, 25 doesn't work. The answer is no. So we end up here is we can pull a negative 1 up front to get that 2 square roots. Square root of negative 1 is I. Square root of 31 we can't simplify any further, so the final answer is 3 plus I root 31 over 4. Again, you're going to do the same thing for the second side. And then the last canvas problem, it's going to be, bring down the 10, should be negative 10. This one works out okay. And it's going to be 10 squared minus 4 times the A value times the C value, all over 2 times the A value. So this one worked out okay in terms of the placement of the numbers. Let's simplify this one. We don't end up with a negative, but the square root of 80 does have a perfect square factor in it. We have 4 does work, so we can do 4 times 20. Got to look at that 20 and decide, is there a perfect square factor in there? And actually 4 is in there, so 16 actually is the biggest number. 16 times 5 will give me the 80. So I'm going to pull the 16 out in front to create the two square roots. The first one I can take the square root of, which is 4. The second one cannot. 10, 4, and 10 all have factors of 2 since they're all even. So if I pull this up, it'll let me separate it. It's going to probably separate this into a fraction. If I try to add this, for example, it's not going to let me do that unless I double click, and then it will change the negative 1 into negative 5 over negative 5 to get us a common denominator. So I will just depend on the form you want it. And so if I want a single denominator or with my numerator being an addition problem, then the negative 1 has to be turned into something over 5, which would be 5 over 5. So again, double click on the addition sign, and it should separate it for you. Then click on the addition sign one more time, and it will combine the two fractions into one. Hopefully this is a real quick explanation of the activity from last Thursday. You're going to continue with 3 additional problems in the next activity. This a word of wisdom in terms of the next activity. I have created goal state problems and Canvas. On the goal state problems, the answer is not shown, but if you do come up with the correct answer, as we did back here, number 1, for example, the rectangle turns green. The rectangle will turn green in problems 1 and 2 if you have the correct answer. The only difference is you don't know what the answer is. It's not given here in the bottom right corner.